In the last class, we studied what is electric current and potential difference. In today's class, we'll see what is electric circuit. Electric circuit is nothing but it is a path for the flow of electrons from current source. In other words, electric circuit is defined as a continuous conducting path between the terminals of source of electricity. Whenever we study electric circuit, we need to know what is electric diagram also. Electric diagram is nothing but a picture where we can see which are the different electric devices are connected to build up the circuit. So, circuit diagram a drawing which shows the way of various electric devices are connected in a circuit. So see, we have electric devices. We need to know what are the different electric devices and the way they are connected in an electric circuit diagram. So let us see a simple circuit diagram, how it looks, in how the various devices are connected. Let's see a simple circuit diagram. First we have cell. This cell is connected to plug key. Just observe the diagram. See, we have this bigger line and smaller line. I'll explain you later what it is called as. This is called as battery or a cell. And this is our switch. And this is our ammeter. And this is bulb. Now just observe, we have a torch. If we on, the light glows. In the same way, this is our switch where we will on and off our appliances. This is a battery and our source which light ups and light offs. So to measure the strength of current, we will use an instrument called ammeter. So for everything we'll have two terminals, one is positive and one is negative. So now you need to concentrate that in an circuit we have one plus terminal and negative terminal in a cell or a battery. Always remember, current starts flowing from positive terminal of a battery and reaches back to negative terminal. So direction will be shown like this. Right? This is a simple circuit diagram. In this circuit diagram, we have various devices. In a similar way, we have few more commonly used elements in an circuit diagram. Let us see how they look and what they are called as. One is cell. Cell looks like, observe, we have one bigger line and one smaller line which are connected to conducting wires. This bigger line always indicates positive terminal and the smaller line indicates negative terminal. So this is our cell. Now battery. Battery is nothing but the combination of cells are called as battery. So the symbol of battery is, this is our bigger line. This is which looks like a battery. We have positive and negative terminal, and this is a combination of cell, right? Now next we have switch. It is also called as plug key. In this switch we have two types, that is open switch and closed one. So it looks like bracket which is connected to connecting wires, and another one closed is like this, but closed have dot in in between the bracket. Here we don't have dot for what? For open plug key. Always remember, the closed plug key shows that current is flowing in the circuit. If the circuit is open, it means current is not flowing. We also have one more symbol used in other textbooks. In our textbook, we have only this symbol. For open, we have like this. And for the close, like this symbol. So just concentrate on this one. Next, we have a wire joint. What is this wire? A conducting wires. See, we have 3 wires which are connected. It looks like T shape. And next we have wire crossing without joining. This is our first wire. We have one more wire which crosses this wire without joining. It looks like this way. And the next one is electric bulb. Electric bulb. This looks like this, or else they will give a bulb diagram. So we need to write this one. The next one is resistor. We still don't know what is resistor. I will tell you in my next topic. Resistor, it is nothing but which resists the flow of current. It looks like, you no need to count and draw this up and downs. You can draw many. And the next one is rheostat or variable resistance. It looks like in this way or arrow mark shown in this way. Now what I said, resistor is which resists the flow of current, right? Now what is this rheostat? See, we have regulator for our fans, right? What that regulator used for? Regulator will use to increase or decrease the speed of fan, right? So here regulator acts as a rheostat which reduces the amount of variable resistance of current in a circuit. So it looks like this, and we have 2 more, that is ammeter and voltmeter. A circle which is connected to connecting wires, and voltmeter same in a circle V. So always remember, these are the devices. Ammeter always measures the strength of current in an electric circuit. Remember, voltmeter measures the potential difference across the wire. Now they may ask you for 1 mark, what is the role of ammeter and voltmeter, and they may ask you write down the symbols for these elements. Practice and remember. So in the last class I told which are the 2 topics we finished. One is electric current, right? That is indicated by the symbol I. And another one is potential difference, that is V. Is there any relationship between potential difference across the conductor and current through it? Yes, we have. Let us explore with an activity. Look at the circuit diagram. We have different elements here. Firstly, we have battery, that is a combination of cells which is connected to resistor, and this resistor is connected to voltmeter, and later on this is connected to ammeter. Ammeter is connected to plug key. See, we have a dot here, hence it indicates current is flowing. Resistor and voltmeter are connected in parallel. Resistor and ammeter are connected in series. So we have our positive terminal here. So hence what? Current flows in which direction? From positive direction. So arrow mark can be indicated indicated like this. Here resistor we are using nichrome wire. Which one? Nichrome. It is an alloy. What is alloy? It is a mixture of metals. Now nichrome mainly contain nickel and chromium. Maybe 80% of nickel, and the next one is chromium. Again it has few more metals like manganese and iron. Nichrome wire is used because it has high resisting stability. It has high resisting stability. Now let us see how this experiment works. Whenever we are conducting experiment, we need a tabular column so that we can record the readings for each different trials, right? So we have a tabular column, number of repetition 1, 2, 3, number of cells. We have 4 cells, right? See here 1, 2, 3. Assume they may have 1.5 volt for each cell. So number of cells 1, 2, 3, 4. Now see, we have the first trial. We need to keep this for first cell. Hence we will get an reading in ammeter and voltmeter. Note down the readings. So for the first one, maybe it will come 1, and just I assume the readings to show what is the end point. We may get current 5 volt. I won't write unit here because I already indicated here. Current unit is what? SI unit, ampere, and potential difference is 5 volt. You need to mention either here or while writing the readings. In the second case, along with the first cell, we need to keep for the second cell also. Then we got a reading maybe 2 ampere and here 10. The same way we need to repeat the trials for different cells. In the third trial, when we connect to third cell, we got 3 ampere as current and here 15. In the similar manner, for the fourth one we got 4 and 20. By looking at the tabular column, what we can notice, as current increases, potential difference also increases, right? Now let us calculate the ratio between current and potential difference. So what is that? V by I. 5 by 1 will get 5, and here 5, and here 5, 5. So what you can observe, the ratio between current through circuit and potential difference across the conducting wires are almost what? Constant. We may get another number also in decimals like 1.2, 2.8. At the end we can observe that the ratio between current and potential difference will be constant. Now let us plot a graph for these readings. So let us take y-axis as potential difference. We need to write potential difference here, that is V, and here current, that is I in ampere. Here what is the unit? V itself. So what are the readings we have? In I we have 1, 2, 3, 4. We can directly take 1, 2, 3, 4. Here we have 5, 10, 15 and 20. Now plot the readings. For 1 current we got 5 volt. In the similar way we got for 2, 10, 3 we got 15 and 4 we got 20. So observe what we got. We got a straight line. We got a linear graph. So graph indicates that as current increases, potential difference also increases linearly, and there is a relationship between current and potential difference, and all these things were given by the German scientist called George Simon Ohm in 1827. In 1827, German physicist George Simon Ohm, he found out the relationship between current through conductor and potential difference across its terminals. Hence, this theory is named after him and called as Ohm's Law. Ohm's Law. It is an important topic in this chapter. Ohm's Law states that the potential difference V across the ends of given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains constant. See, potential difference is directly proportional to what? Current. So, it can be written as V is directly proportional to I, that is potential difference is directly proportional to I, and next it is written as V by I is equal to constant. Ohm represented this constant as R, that is nothing but resistance, hence it is written as V by I is equal to R and V is equal to I R. This is the mathematical form of Ohm's law. Always remember this statement and as well as equation. Here V is what? Potential difference, and I is current. R is what? Resistance. In the next class we will see in depth what is resistance. Now let us solve few problems regarding this Ohm's law. Look at the problem. How much current will an electric bulb drawn from 220 source if the resistance of the bulb filament is 1200 ohm? So here, what are the given things? Volt is 220 and here what is resistance, that is 1200 ohm. Recall the formula of Ohm's law. V is equal to IR. How much the current? Current should be find out here. Substitute the values in the formula. Before that, alter the formula to find out current. I is equal to what happens? V by R. Right? V is what? 220 volt and R is what? 1200 ohm. Calculate and see how much we will get. We will get 0.18. What is the SI unit for current? Ampere. So it's very simple. Just write down what are the given things and which you need to find out. Anyhow, we will be knowing the formula. The important thing is we need to alter the formula in such a way which one we need to find out. Don't make any mistakes like R by V here. Substitute it properly. The next one, B, it is also same way. They are given V as 220 volt and here R is 100 ohm. Here also we need to find I only. What is I? V by R. What is V? 220 by 100. So calculate and see how much we will get. 220 by 100 is nothing but 2.2 ampere. This is the simplest problem which you can easily get marks. Look at the question carefully. The potential difference between the terminals of an electric heater is 60 volt when it current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? Read out the question. We have two questions in this single question. The first, they are given potential difference, that is V is equal to 60 volt, draws a current, that is I is equal to 4 ampere. We need to find out R here. And see in the second statement, what is the current? We need to find out I. Will the heater draw if the potential difference increased to 120? V is equal to 120. Using this R, we need to find out current here. So according to Ohm's law, what is the formula? V is equal to IR. We need to find out R, and the formula will become V by I. What is V? 60 and 4. So what will be the answer? 15. What is the SI unit of resistance? Ohm. So this is answer for the first part. And in the second part, again use the same formula, that is V is equal to IR. We need to find out I here, and what will be the formula now? V by R. What is V? V we have here, that is 120, and R is here 15 ohm. Now calculate current. So we'll get 8 ampere. So look at the formulas and the problems. They are very easy. Just practice and try to solve all the numerical problems. In today's class, what are the things we covered? We learned what is electric circuit and different elements which we use in circuit diagram. And the next one is we mainly learned about Ohm's law and few problems. In the next class, we'll see about resistance.